Okay, so the first thing I want to go over, usually with this group, everybody has been in Blackboard, but I want to double check. Is there anybody in here that has not accessed Blackboard yet? Okay. Generally by Friday, everybody's been there. We are out there in this class. There is nothing on Blackboard that is required for this class, but there are things that are pretty helpful. Your official grade book will be kept on Blackboard. Again, you don't have to look out there to find your grades. You can always ask me and I can tell you. But that is one of the buttons when you go into Blackboard. You can click My Grades and they'll be out there. There's nothing in there now, obviously. In fact, I don't even have the assignments put in there yet, but we'll talk about grades in just a minute. There will be this opening announcement that tells you where everything is. Course Tools, like any other class, has email and stuff, so you can find, you can email me or other students in the class if you want. The big button is the course information button. That has my contact information in there. Best way to reach me is email. I have the computer here. I usually check email at least a couple times a day, so I'll get those pretty quickly. If you can't get to a computer for email and you need to call, you can actually call any campus phone, any WITC phone number, the 800 number or any of the campus phone numbers, and then put in my extension 5361 and it will go to my voicemail. Don't expect me to answer because I'm never in my office. I go up there maybe twice a week to make sure nothing's piling up on my desk, and that's about it. If you ever saw the offices here, you'd know why. But I do have it set up so I get sent a message when someone leaves a voicemail. So I'll get that relatively quickly as well. I'm going to come back to the syllabus in just a second. Other things that are posted here, my schedule is there if you need to get a hold of me or come in and see me. That'll show you when my office hours are. For this class, I am available right before and right after every Friday for the hour before and hour after. So those of you here, if you need to come in and see me, feel free to come on in. Other locations, if you send me a message and let me know that you need to see me, I can go down to the ITV office and they can have the meeting come up early or stay late so that we can go over whatever you need to there. Or we can just set up a phone conference. Assignment schedule. If you look at that, this is a rough estimated assignment schedule. Not going to actually go through it. You can see it's listed for 16 weeks, but the last exam is listed in week 15. This is because we almost always lose a Friday with holidays or whatever. The 16th week is for extra if we happen to get one. Every couple of years, we do get the full 16 Fridays. That is estimated. I will show you if you want to be exactly sure of what was assigned that week, just go to the end of the videos, and at the end of the videos, I'll make sure I put the assignments up each week as well. But this gives you an idea if you have to miss or if you want to work ahead, it'll give you a rough idea. You can see exam 1, by the way, is in the first hour of week 3, so that's 2 weeks from today already. Will be your first exam. I know, it's quick, but also out here on this page, on this tab, you see homework solutions here. That is solutions to the homework problems that will be in the book. I do not collect homework and grade it, partly because with the ITV setup, it's a lot of transferring papers back and forth. Also, I view homework as a tool to learn, not to grade. You guys, if you guys do a couple of the first ones and they're really easy, I don't mind if you skip ahead to the more difficult ones, just as long as you are ready to take a test on them or you thoroughly understand those topics by the time you're done. So those are there so you can double check. The syllabus is also here. My contact information is there again. You guys are here, so I don't need to go over when and where the class meets. This class is designed specifically for the medical fields. It was designed originally for the associate degree nursing, but it's been modified now for RN and paramedic. So we have a lot of the materials you guys need there. The big purpose was dosage calculations, but to make it a college level course, we had to put other things in there before it would be approved by the state. But it is pretty specific about, I'd say about 2/3 of the material is specific to what you need for dosage calculations and stuff like that. Your textbook, you probably can't see it on camera. but it is the Math for Health Sciences by Joel R. Helms, published by Delmar. Soft cover, pretty thin little book. How expensive is that getting, by the way? Does anybody know offhand? 70 for you, 90 for you? That's not bad, actually, for this. One of my other classes, they told me that the book was up to $340. I know $100 sounds like a lot. Yeah, the hardcover general AMPs are probably over 400 now, aren't they? Or close to it. Okay. Yeah, the textbook market has really just gone nuts. Okay, other materials. It's not required, but it is extremely highly recommended that you have a scientific calculator for the class. So by scientific calculator, I mean anything that's capable of doing fractions. Mostly the one, if you don't have one, the one I recommend is the Texas Instruments TI-30. If you have a graphing calculator, you're welcome to use it. The problem with most of the graphing calculators is most of them do not do fractions well. Texas Instruments TI-30. And tell you, usually I get the TI-30 Model 2. That's a 2-line display. There's the gray or black ones, or usually there's a white and blue one that's it's a math type version. It's a couple dollars more and it's fancier than what you need. But there's one that's either gray or black. It's a 2-line display that usually works. It's usually the easiest one to use. Is anybody in here? Yeah, if you want to hold that one up for everybody here. You guys can't see that one at the other sites, but it's that dark gray, black, or even a dark blue like that one. What's that? This free? Yeah, they're between $10 and $15 depending on where you find them. If you have a choice between battery or solar, I usually recommend solar just because I have probably 7 or 8 of them up in my office with dead batteries, and it's like $6 or $7 for batteries. And the calculator was, I think, $10 to begin with. So anyway, if you have a calculator and you're not sure if it's good enough to get you through, let me know. I'd be happy to take a look at it and make sure. Pretty much any calculator will get you through this course. Some of the graphing calculators do statistics and stuff like that, which is neat, but way more than what you need for here. No. Well, we are going to do some basic graphing. If you have one, it'd be great to use, but I would not recommend going out. No, because they're like 120 or $130. I wouldn't spend that money for what we're going to do. And what we're going to do is pretty basic. Okay, so the competencies are out there. We have 5 units in this course. The first unit is basically math concepts, arithmetic and basic algebra or pre-algebra. Our operations with numbers, working with ratios, percents, and then our basic working with variables and solving equations. And of course, the thing you're going to learn to hate by the end of the semester is word problems. Now, people tend to groan about that, but life is a word problem. Okay, so then our second unit is where we start to get into stuff that's really important for the dosage calculation things, and that is our measurement and measurement conversions and equivalencies. So that'll be in our second unit. The third unit is the dosage calculations. Any extra time I can milk out of the course, I try to put into that, because that is the one that really is kind of the heart of this course. Then the last 2 units are units that are prepping you for the next step. If you're in nursing, it's already come out that at some point you're probably going to be required to go on for a bachelor's degree. If you go on for a bachelor's degree, there's 2 courses you will have to either test out of or take. That would be either a college algebra or intermediate algebra, and then a statistics course. So our last 2 units in here are a little bit of the fourth unit is a little bit of an algebra prep, and the last unit is a small introduction to statistics. Not as painful as they sound, I swear. Statistics is one of those courses, by the way, if you are going to go on to a 4-year degree, We offer a version of statistics here. It's only offered online and only in the springs, but it is, I would say, a little bit more user-friendly than what you would get if once you transfer out. I have taught the statistics course for Viterbo, Lakeland College, and Franklin University. Our version is easier than any of those. So just a little planning for the future. If you have questions about it, feel free to ask me. Your grades for this course. Your grade for this class will be completely determined by the average of your 5-unit tests. That's not as scary as it sounds. Like I said, homework and stuff like that is just too difficult to grade with the distance. I have some classes on ITV that we have set up with an online homework system. This textbook does not have that. We couldn't find any good math for health textbooks that had that system. So it is all 5-unit tests, but the saving grace is once I grade that test and give it back to you, you are welcome to redo any of the problems you got wrong and turn it back in and get up to half your points. So let's say you have a really bad day and you get a 70% on a test, you redo it, you turn it back in, that turns into an 85. When you redo those, by the way, and I'll talk about it more when I pass back the first test, when you redo those, you are welcome to work with other students. You are welcome to come ask me, and I will sit down and work through the problems with you if I have to. The big purpose there is I want to make sure you have seen how to do it correctly before we're done, and that you have it down somewhere. When you do those, I do require you show your work. Okay, our grade scale, you've probably seen this one a few times already. That is the standard WITC grade scale, the letter grade to percent conversions. If you have to drop the course for any reason or withdraw, please talk to me. A lot of times, if it's work related or something like that that's coming up, there's often ways we can work around it to keep you in the course and get you credit. If you think you're struggling in the course, usually you're not doing nearly as bad as you think you are. So talk to me first and we'll see if there's something we can't work out before you withdraw. There's 5 major tests. Well, the first unit test will be 2 weeks from today, and that will be posted, that score will be posted in Blackboard within a week of you taking it. So you'll have kind of a running, yeah, you'll have kind of a running total there. Okay, they told me I have to talk about academic integrity this year. Don't cheat. That's probably all we really need to cover. I mean, the homework, you're welcome to work with each other because it's not graded. You have the answers to check your papers. So all we really have to worry about is don't cheat on the unit tests. And if you guys are anything like me, I don't trust somebody else's answers more than my own. So we should be okay there. If you have any needs, whether you have a diagnosed disability or maybe you just have problems taking a math test with a camera on you or anything like that, come and talk to me. We can always, or send me an email if you're at another site. We can almost always find something to make you more comfortable. You'll see the first couple of tests. We have a test and then we will continue on with new material in the second half of class. That's one of the problems with the 2-hour class. Generally what we will do with those is we'll start the test right at 10:30 and usually at about 11:30 we'll take a 10-minute break. If there's people still working, we'll start lecturing depending on how everybody's doing with it, somewhere around 11:30 or 11:40. You do always have unlimited time for tests. So if you need more time, please feel free to set it aside. And then after class, you can continue working on it. Or if you have to come back and finish it later, we can hold on to it for you and you can come back and finish it. The only thing I do with that is if you do have to leave and come back, when you come back, you have to finish it in that sitting. I don't want someone coming, working on it for a while, leaving and coming back like over 5 or 6 different days. And those are required to be completed by the next class. I have to have time to grade them and get them back to you. When we take a test, I will always have it back to you by that next week, that next class. Any questions on grading? Okay. And then, of course, my official notice, the videos are publicly posted. They're on YouTube, so anybody can see them, so you've been warned. And those are our 5 units. Like I said, arithmetic, measurement and conversions, dosages. Unit 4 is that basic algebra with an emphasis on graphing, and then finally basic statistics. Okay, enough of the administrative stuff. Anybody have any questions about the course or the grading or policies before we move on? Sorry. You wouldn't think you have to get in shape to sit here and talk all day, but I am wiped out at this point. Okay, so this class starts out with arithmetic and some basic math. The reason for that is we found through the years that many of the problems students have when they get into the more advanced concepts like the algebra come from the fact that they really didn't understand what they were doing with the arithmetic. We tend in this country to teach how to do math, but not why we're doing it. For example, one topic that I run across that is a very basic topic in math, but is often not completely understood, is the idea of a number. For example, if I put a 4 up here, show of hands, how many of you would tell me that that's a number? Most people would. Some of you are suspecting something right now, so you're holding back. But 4 is an amount. It's what we would refer to as a numeral. It tells us how much. But to completely be a number, we not only need to know how much, but of what. For example, we might have 4 cows. So here we have 2 parts here. The 4 tells us how much. I'm going to refer to that as the count. And then the cows tells us of what. What do we have 4 of? I'm going to call that the name. And it is very important for numbers that we keep both of those in mind. Now, some of you might be thinking, oh boy, here's another one of those guys that's going to make us label everything, label all our answers. That's not really my purpose here. In this class, it is important we label our answers because with medical calculations, we need to know if that's microliters or milliliters. So on a lot of the tests, there is 1 point per problem for those units, but that's not really my purpose of pointing this out here. The reason I do is because those 2 parts of a number explain why we do our basic math operations the way we do. Let's look at our 2 most basic math operations of addition and multiplication. Well, first of all, at this point, you might be wondering, well, where did subtraction go? And maybe even division. Well, addition and subtraction are really the same operation. They're 2 sides of the same coin. Addition is going forward and subtraction is going in reverse. So anything that we talk about for addition, subtraction follows the same rules. In fact, subtraction is defined as part of addition. The same goes for multiplication and division. They're both really the same operation. One is going forward, the other is going in reverse. If we look at adding numbers, if I have something like 4 inches plus 7 inches, what do I get? 11 inches. If we look at the counts, we have 4 and 7, and we ended up with 11. We combine the counts. Any math operation, we're going to combine the counts. Here we're adding, so we combined them with addition. The significant difference is going to come with the names. Here we have inches and inches, and we ended up with inches. When we add and when we subtract, we end up keeping the same name. Well, let's look at how that's different when we multiply. Let's multiply 4 inches times 7 inches. What are we going to get? 28 what? Not inches, but inches squared. If you think about it, if we're doing 4 inches times 7 inches, the only application where we would do something like that would be finding an area of a rectangle or something. So we'd be getting square inches or inches squared. So if we look at what happened with our counts, well, 4 and 7 became 28. we still combine them. We're multiplying this time, so we combine them with multiplication. But we always combine the counts. Again, the difference comes with the names. We had inches and inches, and we ended up with inches squared. When we multiply and when we divide, we're going to also combine the names. This little point here describes why we do everything the way we do with all of our other forms of numbers. We've been taught that there's separate rules for adding, subtracting, multiplying, dividing fractions, decimals, algebraic numbers, or sometimes called polynomials, scientific notation. It's not true. They all follow these same procedures. They look different because the form of the number looks different, but it's all the same. In fact, this little difference between the operations even defines what we can do, what numbers we can use in each operation. For example, let's say we have 3 cows plus 5 boys. Am I going to get 8 cowboys? No, it doesn't work that way. Or if I switch it around, if I did 5 boys plus 3 cows, would I get 8 boy cows? No. Anybody with a farm background in here? A bunch of us. Well, then you can tell me that this is a, come on now. Been having computer issues all day getting this thing to work. You can tell me this is a bunch of bull, right? All right. A long way to go for a joke, but there's a point behind it. By the way, I'm a math teacher, which means I'm required by law to have a really stupid sense of humor. You'll get used to it. There's a point behind this one, though. When we add or subtract numbers, we are going to keep the same name, which implies that we had to start out with the same name, inches and inches, so that we could keep it and it'd stay inches. Here we have cows and boys. They don't have the same name. We don't know which one to keep, so we can't combine them. If we try to add 3 cows and 5 boys, we end up with 3 cows and 5 boys. On a little bit more practical note, if we had 5 feet plus 2 pounds, they don't have the same name. I cannot add those. I can't combine them with addition or with subtraction. So I end up with 5 feet and 2 pounds. On the multiplication side, though, 5 feet times 2 pounds, when I multiply or divide, I combine the counts. What's 5 times 2? 10. But I also combine the names. Feet times pounds are foot-pounds, which is a unit of torque, or if you're looking at structures or bone stress, it's a unit of moment. Foot-pounds is a measurement of stress on joints and stuff like that. When I multiply or divide, I don't have to have the same name because I'm just going to combine them. This actually explains why we do things the way we do with our whole numbers. It comes down to a concept of place value. Place value is another one of those concepts like numbers that is one of our basic concepts, but isn't usually fully understood, and its importance is usually overlooked. Just a quick review. If we start at the end of the number, what's this last place value? Ones. And then tens and hundreds. Those are actually our only 3 place values. They are repeated over and over again. Ones, tens, hundreds. Ones, tens, hundreds, and so on. That first set of 3 was our base group. Then we have the thousands group, and millions group, and so on. So when you name a place value, this would be the tens. This would be referred to as the 10,000. It's the tens place in the thousands group, and so on. When we look at a number, We are used to seeing like 365 written as a number. That's actually just an abbreviation of the number. The full number would look like this: 3 hundreds and 6 tens and 5 ones. That is the full form of the number. Many of us may have done this and had it referred to as expanded form. That's fine, but that's really all of the information contained in that number. If we go to add, let's say we're going to add 200 and, well, let's go 13 to that. Well, that is 200 and 110 and 3 ones. When we were taught to add numbers, we were told add and subtract. We were told you got to line up those columns with the numbers. The reason for that is actually apparent in this full form of the number. Each digit of a number has a count and a name. This isn't just a 5, it's 5 ones. This isn't just a 6, it's 6 tens. When we add or subtract, we can only combine things that have the same name. That comes right down to the place value. These ones can only be combined with the other ones. The tens can only be combined with other tens, and hundreds with other hundreds, and so on. That's why we line up the columns and we add or subtract straight down. Now that it's lined up, of course, 300s and 200s is 5. We keep the same name. 6 tens and 110 is 7. We keep the same name of tens. 5 and 3 is 8. We keep the same name of ones. So 578. Some of you might have caught that I did something a little strange there. What was it? I went left to right, yes. We've been taught you always go right to left. I'm not going to get too far into details on this. But let's do an example. What the heck? Let's say I've got 784 plus 197. The reason we normally start on the right and work our way back to the left is in case we have to carry. 4 plus 7 is 11, so we can't have 2 digits in one place value, so we keep the 1 and we carry the first one. 1, 8, and 9, 18. So again, we're going to keep the 8 and we're going to carry that leading 1. 1, 7, and 1 is 9. So we got 981. That process of carrying is actually a relatively new process. Before carrying was popular, one of the ways that this problem might have been done might have looked like this. Now, you don't have to write this down. I'm not going to try to change the way you add, but I'll get to my point here after I show you the example. They've done 7 plus 1 is 8. 8 plus 9 is 17, so 7 drop the 1. 4 plus 7 is 11, so 1 drop the 1. 8 and 1 is 9, 7 and 1 is 8, and 1. Get the same answer. It's a little more work, a little longer. That's one of the ways it could be done. I could actually show you 3 or 4 other ways, but I'm not going to because I don't want to confuse you. But the reason I'm showing you this is we've always been taught in math there's only one right way to do things. That's not true. Pretty much everything we do, I could show you at least 3 or 4 different ways to do it that would always work out the same answer. Just because you have a way of doing things that's different from what I do does not mean it's wrong. I'm going to get on my soapbox for just a second here. When you get down to psychology and brain chemistry and brain psychology, it's actually been proven that the human brain is hardwired to do math. Now, a lot of you are probably sitting there thinking right now, not mine. I hear it from students all the time. I'm terrible at math. I can't do it. My brain doesn't work that way. Yes, it does. There's 2 things that affect your level of math ability. One is how you developed it when you were young. A lot of experiences, again, the brain psychology and the research, developmental research has shown between the ages of 3 and 10 are and sometimes some even say 3 and 8 is your key window for the rapid development of some of those parts of the brain. Comes down to what toys you played with, Legos, blocks, Lincoln Logs, stuff like that, rapidly develop math skills in the brain. So your development, and that's the point, is part of it as well. The second thing that affects that math development in the brain is your style. Math is about patterns. If you see the patterns, the concepts in math make more sense and the calculations become a lot easier. One of the patterns is what I was just showing you up above here about the count and the name. And we'll see that pattern held true with our other forms of numbers today as we go through. The problem is not everybody sees the same pattern. So as you are learning math, you hit some critical milestones. One of those is fractions, when you first learn fractions. The other is when you first learn algebra. And there are several other ones. Well, if you are working with a teacher that is teaching a specific method and that pattern doesn't match up with the way your brain thinks, it's not going to make sense to you. So you can learn math. I don't care how math deficient you think you are. You can learn it. There's the two things that are required is finding the way that your brain works so that you can learn math in that way. And then the second is the time required. I mean, the only difference between someone that's bad at math and good at math is time. If you spend enough time, you will eventually find the way your brain works and get to it. Okay, off my soapbox for now. But it is kind of interesting to see that math is the one topic that everybody's brain is capable of doing, but so many people have not done it because they haven't met a style that's the way their brain works. A lot of the complaints you see about the current math curriculum in schools, by the way, is because they're trying to teach patterns. The problem is they're picking a pattern and trying to teach it, and not everybody's brain sees that same pattern. For example, if you look at shortcuts, like if you have 47 plus 9, I do a lot of math, so obviously I find shortcuts and patterns that help me think, or it would drive me nuts. I'd be swerving at a light pole on my way home at night some nights. I look at a problem like this and I'm thinking 9 is 1 less than 10. So 47 plus 10 is 57. 1 less than that is 56. So 47 plus 9 is 56. Now, obviously, I'm thinking that all in my head rather quickly when I do that, but that's the pattern I see. Others might look at that same problem and say, okay, 47 plus 9, we're going to do this. Here's 47. I'm going to split that 9 into 3 and 6. Why 3 and 6? Because it takes 3 to get that to 50, and 6 gives me 56. There are several other patterns you could see. If I tried to force you to learn one of them, it might not be the one that you make and that you see, and it's just going to frustrate you. One, it's going to make you hate math, and two, it's going to make you think you can't do math. I think I slipped back on my soapbox again. I'm sorry. So, on to our other stuff. Subtraction obviously works the same way. Similar to addition, I could actually show you several ways to subtract that would work every time. If it's something you're interested in, talk to me sometime outside of class and I'll show you. Multiplication. Let's say we have 23 times 31. If we write those out in their full form, 2 tens and 3 ones, and then 3 tens and 1 1. What we set up above, when we multiply and divide, we do not need the same name. So what that means is these 2 tens can not only be combined with these 3 tens, they can also be combined with the 1 1. In fact, every digit in one number can be combined with every digit in the other number. And that's all long multiplication is an organized way of making sure every digit in one number gets combined with every digit in the other number. Now, depending on what region you learned multiplication in, or sometimes even what country it's being taught in, the position and where you start and the pattern you go through is different, but it's basically the same process. In this region, we're taught to start with the last digit of the bottom number. So it's the 1 1. And then we combine that with all of the digits in the top number, starting with the last one. Again, working on the right and going to the left. 1 times 3 ones. Well, 1 times 3 is 3. But we have to remember to also multiply the names, the place values. 1s times 1s is 1s. Then we move to the next digit in the top number, which is the 2 10s. 1 times 2 10s. What's 1 times 2? 2. But again, we still have to combine the names, the place values. 1s times 10s is 10. Now we've done everything on the top, we've done every digit in the top number. We can move over to the next digit in our bottom number. What have we been taught that we have to do down here when we do that? Put in a 0 here, or some textbooks just tell you to leave a blank spot there, depending on, again, where you learned. The reason for that 0 there is what's going to happen next here. We're going to take our 3 10s and multiply the 3 1s. 3 times 3 is 9, but we also have to combine the names, those place values. 10s times 1s is 10s. We had to have that 0 there so we keep our place values lined up. Now 3 10s times 2 10s, well, 3 times 2 is 6. 10s times 10s is hundreds. So we go ahead and 3 and 0 is 3, 2 and 9 is 11, so 1 carry the 1, 1 and 6 is 7. So 713. Now, I understand, and the first test that we take, by the way, it's going to be split into 2 halves. The first half is going to be these basic calculations where I ask you to do them without a calculator. Now, you can go back later and double check your answer, your calculation with the calculator. If you have accommodations, if you have any sort of disability, if you have calculators allowed, you can use the calculator. But on those problems, I will require that you show the steps. Now, I'm not going to require you to show the count and the name like this, but I would require that you have it written out at the very least like this, and add them up. You'd have to show that on your work. You can use a calculator to double check them again, but you have to show that much on that first half of the test. The reason I bring up the calculators again is I understand the calculators exist, and when possible, you're probably going to use them. I would hope that you would look at some of these problems like we've done here, like our addition problem here, and before you punch it in the calculator, just take a little look. The way I would estimate it is I'd say, okay, 784 is about 800, 197 is about 200, that's close to 1,000. I'm expecting an answer around 1,000. My calculator spits out 981, I know I'm in the right ballpark. I have these clumsy sausage fingers, so I have problems with the calculator, to be honest. So it's not uncommon for me to go to do something like that. 784 plus 197, oh, 2771. What happened there? Yeah, I hit an extra key. I might have hit 2 keys when I was going for 1. Or I can have something like this. 784 plus 197. What happened there? One of my keys didn't register when I tapped it. Having an estimate in your head before you type in the calculator will keep you from making these major mistakes like this. The calculator is always right, so our tendency is to punch it in and write down what that number is and not think about it. But have that little bit of an estimate. This is the way I estimate it. You can come up with your own estimate. Like I said, everybody sees it different. So whatever makes sense to you that helps you catch those mistakes. Please just do some sort of an estimate before you punch them in the calculator. Like here, I would look at this and say, okay, that's about 20 and about 30. That's about 600. 713 looks a little large, but both of these numbers are bigger than the 20 and the 30, so I expect my real answer to be bigger than 600. Okay, we've got a few minutes before we hit break, so let's talk a little bit about fractions. A lot of people cringe when we say fractions. If I asked people as they walked into the classroom what they dislike the most about math, I'd say probably 4 out of 5 would say fractions. The main reason for that is because we tend to treat fractions, especially at the lower levels when you're first learning them, which is the critical point, treat them like they're something totally different from everything else. They're not. Let's look at something like 4/7 here. That top number is called the what? Numerator. The bottom number? Denominator. Well, what does it mean to numerate? Every 10 years, our government does a census where they send out people in an attempt to numerate the population. What are they doing? They are counting. It's a count. A denominator. Well, we have different denominations of money. We have different denominations of organizations. To denominate means to classify or to give a name. People look at fractions and they see two numbers, but it's really not. It's just a single number with two parts. Just like having 4 inches or 4 cows, here we have 4/7. After break, we'll talk about what does it mean to be a seventh. But let's take a look now at how that fits with what we talked about at the very beginning with our whole numbers and the adding and multiplying. If I have 4/7 plus, somewhere back in 3rd grade when you first learned to work with fractions, that 3rd grade teacher told us to add and subtract fractions, you must have a common denominator. That is not a special rule for fractions. If you remember back up top, when we add any number, we must have the same name. So that common denominator for fractions is just having the same name. When we add, we were taught you combine the numerators. 4 plus 2 is 6, and then you keep the common denominator. Again, that's not a new rule for fractions. Anytime we add numbers, you combine the counts, and then you keep the same name. When you multiplied, if I had 4/7 times 2/7, how were we taught to multiply fractions? You're thinking division. Just going straight across. Numerator times numerator, 4 times 2 is 8. Denominator times denominator, 7 times 7 is 49. Again, it's not special rules. I'm actually glad some of you guys stumbled and brought up different rules. That's one of the problems with fractions is we have all these different rules memorized, and trying to remember which one goes where can be difficult. This is the same process as whole numbers. We multiply the counts, and then we also combine or also multiply the names. If we don't have the same name, if I have 1/4 plus 3/5, can I add those the way they're written? No, just like our feet and our pounds, we couldn't add them because they had different names. Multiplying, however, do we need a common denominator to multiply? No. When we multiply or divide, we don't need common denominators because we're going to also combine the names. So 1 times 3 is 3, 4 times 5 is 20. So all those special rules we learned for fractions are not special. They're the exact same rules we saw for other numbers. Yes? Yep. Yes, in fact, after break, we'll look at finding the common denominator and combining those. It is break time. It's 11:21 actually, so let's take 10 minutes. We'll come back at 11:31 and start up again. If you're here in Rice Lake, our clocks are way off. They're about 4 minutes slow, just so you know. So if you're looking at the wall, that would be at about 11:27 or 11:28, you'd have to be back in.